Welcome. We're going to do a review or a walkthrough of an answer key of the problem set 1. So hopefully this will be a little bit helpful to you, especially if you struggled with the math. If you struggled more with the Excel part or trying to do the graph in Excel, there are some other videos that can help. So we're going to start first with problem number 1. Question 1 was about budget constraints. So in this case, we had our budget constraints. We say Samantha had a weekly allowance of about $85. So she had $85 to her name. And we can think about this as her budget or her income. Or I for income. And then it says that she wants two things, smoothies and she wants thrifted books. Each smoothie is a cost of $8.50, and each thrifted book itself is $3.25. So I have 3 pieces of information, and this is key for us to build our budget constraint and then to graph our budget constraint. Because the first question asks us to do our budget constraint. So remember, a budget constraint looks a little bit like this. It is the price of the first good times the quantity of that first good. So that's the total amount you're spending on this first good, plus the price of your second good times the quantity of your second good. So this is how much you're spending on your first good, and this is how much you're spending on your second good. And then this is going to be equal to, sometimes it's written out as B for budget, sometimes it's I for your income, but that's equal to your budget. And your budget is your constraint, and that's why we call this a budget constraint. You can only spend as much money as you make or as much money you have in your budget. In this case, we're going to say that smoothies is our P1 and books are our P2. Right? So what we're going to do is we're just going to plug our values in. So our budget constraint is going to look a little bit like this. We spend on P1, our smoothies, we spend $8.50. If you want to change the Q, you can. I'm going to say Q, and I'm going to write a little s to say that's my smoothies. So this is the price of a smoothie and the quantity of smoothies I purchase. We add to that our books. Our price of a book is $3.25. We can multiply that by our quantity of books. And that's going to be equal to our budget. And our budget is $85. We have $85 to spend. And that is the answer to the first question. First part of this is the answer, right? Question 1. The second thing it asks us to do is create a table of values. So a table of values is like our points that we can use to plot this. And when we plot this, we'll plot this like on our graph. We'll have our 2 axes. We'll talk a little bit more about that. So we need to create a table of values. A table of values is going to look a little bit like this. You can do it out by hand. You can do it out on Excel. We got smoothies on one side, and we got books on the other. Remember, to be able to consume more smoothies, you have to give up books. And to be able to consume more books, you got to give up smoothies, right? That's the opportunity cost, or the cost of one thing to give up to the other. In this case, right, I would start with something simple, right? So mathematically, we can look at this equation. 8.5 and 85 have a relationship. 8.5 times 10 is 85. So we know that the maximum amount of smoothies we can have then is 10. So if we just do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1 at 10 down at the bottom. Right, so now we can say, all right, so we consume 2, 3 smoothies. The next thing we need to do is plug in these values, right? we need to find what quantity of books we consume based on how many smoothies we consume. So we need to fill in this table. Easiest way to do this, I would recommend, is to use a calculator, of course. What you end up doing is something that looks a little bit like this. So I'm going to plug in values into this equation. I know I'm going from 1 to 10 for smoothies. The cost of a smoothie is $8.50. If I consume one smoothie, I now need to figure out how many books I can consume at the same time. Right? In that case, what I'm trying to figure out is what this value is going to be. Right? We're trying to find out the quantity of books. So I'm going to solve this out. $8.50 times 1 is $8.50 plus $3.25 times that QB equals 85. Next, I'm going to subtract this $8.50 from both sides. Minus $8.50, minus $8.50. That way I can isolate what I have left. Right? So $8.50, 85 minus 8.5 is going to leave me with 76.5. And that's going to be equal to that $3.25 per book. Now I divide both sides by this $3.25. And I get roughly, if I consume at least one smoothie, I'm going to get around 23 books. Right? This is going to be 23.5, but you can't consume 0.5 a book. So we're going to get around 23 books. Right? And then I go over to my table and I fill in that value. And then I do the same process over and over and over again. And then I'll get, for 2, I'll get about 21 books. 3, I'll get about 18 books. Remember, we can just, this is indicating to us we're rounding. We're just rounding to the next one. 16-ish books. 13, 10, 7, 5, and 0. So, what we can do now with this is we can plot these. So I'm going to get rid of this. And we're going to just plot these points. So when we draw something out like this, we want to make sure we have our two axes. In this case, we're going to say that our y-axis is actually going to be our number of books. Or the quantity of books, if you want to put that Q back in. Q books. And our x-axis, this horizontal one here, is going to be our smoothies. Right? Or that S. Or QS. And then we're going to plot our points. So we're going to move smoothies over, up books. 1 smoothie, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And there should be a 0 here. Over smoothies, up books. Books, I'm going to go by like 5s. 5, 10, 15, 20, 25, 30. So, 1 smoothie is going to be like 23 books. 1 smoothie, 23 books. 2 smoothies, 21 books. 3 smoothies, 18, 16, 13, and so on and so forth, right? It keeps going down until we reach 10. It should be pretty much a straight line where we cross at certain points. You also need to find where this is going to be 0. And at 0, these are where we cross our axes, and this is telling us if I only consume books, how many books can I consume? If I only consume smoothies, how many smoothies can I consume? Well, if I only consume smoothies, I can consume 0 books. I can get 10 smoothies or 0 books. If I only consume books, and I consume 0 smoothies, I can get about 26 books. The last piece we need to do is we need to do our opportunity set. Because remember, we can actually consume anything underneath our budget. All these things are possible underneath our budget, right? That's our opportunity set. We can consume anything underneath our budget line because we have the budget for it. We're just going to spend less than our budget if we consume. But we cannot consume above our budget constraint because we don't have the money for that, right? That's too much spending, too much money. The second question in the problem set is a demand shift. So in this case, right, we have our supply, we have our demand. Supply is that upward slope, demand is the downward slope. Our law of demand is saying to us the increases in price, the less people want to consume. The more expensive something is, the less you consume it. The cheaper it is, the more you want to consume. Our upward slope in our supply is saying the opposite. The higher the price, the more supply there is because the more money you can make. In this case, we have the town of Dennis loves pastries. Before a trendy new shop opens, the market is described below. But after a popular influencer posts daily about the new pastry shop in Dennis, demand rises. So we're going from this is our first demand, and we're going to our second. This demand shift is caused by this trend, right? This influencer comes in, this good or this service is becoming more popular, and it causes our demand to shift upward. More people want to consume it. So what we need to do first is we need to find our equilibrium. We need to find first where these two things are meeting, and then we look at our equilibrium shift. So the first thing we're going to do is we're going to find equilibrium, remember we have to set two equations equal to each other, and then we can solve the rest out. So what we're going to do is I'm going to set these two equations equal to each other. I'm going to try to find P, and then I'm going to plug the value back in, and that's how I'm going to find both quantity and supply. Both quantity and price. So we have 500 minus 5p, and remember that minus 5p is our negative slope. So that's telling us the relationship between quantity and price. That's telling us how quantity demanded shifts when price shifts. And that's going to be equal to our 50 plus 10p. Remember that 10p is our positive slope. That's telling us how many more units or the quantity supplied, the increase in quantity supplied there is to the relationship in the increase in price. So in this case, we're just going to solve this out. I'm going to add 5p to both sides. That's going to give us 500 equals 50 plus 15p. Nice. Now we're going to subtract 50 from both sides. That's going to give us 450 equals 15p. We can look at and we can focus mostly right on that 45 part. So 15 goes into 45 3 times. Add the 0. That means our price or equilibrium price is going to be 30. Cool, we found that. Now our next step, we need to plug this back into our equations. And we're going to plug that back into both of them just to make sure we did our math correct. so I'll pick the first one. We're gonna go demand first, so we're gonna plug that back in. We're gonna say 500 minus 5 times 30. All right, 500 minus, that's gonna be, what's that? So we got 5 times 3 is 15. This is 150. 500 minus 150 is 350. We do the same thing with supply. We got that 50. We're going to add 50 plus 300, 350. Beautiful. Our original equilibrium then, right? Our first equation wants our original equilibrium. Our original equilibrium is at a price of 30 and a quantity of 350. First question answered. Our second question is now asking us if this shift occurs. We have a new equilibrium. What are we going to do? We solve it the exact same way. Now we just want to plug in this new demand instead of our old one. All right, our new demand is this 600 minus 5p. This is telling us that at our axes, we went from this to this where we crossed. So all we had was that shift up of our demand. And remember, demand's downwards, so it looks like this. It shifted upwards. So we got 600 minus 5p, that's got to be equal to our supply. Our supply is at 50 plus 10p. Same exact math. Add 5. We get 600 equals 50 plus 15p minus this 50 from both sides. So we're going to have 550 equals 15p. Then we have to divide both sides by 15. And that's going to give us a price of about $36.67. What do we do now? We take this and we plug it back in, right? And then we solve for our quantity. Now, I didn't leave as much space, so I want to be quicker with this. All right, demand. We're going to put that in, that 5, that's new one. 600. 600 minus 5 times 36.67. 67 is going to be 600 minus 183.55, and that's going to be 416.65. 416.65. So our price was 36.67, and our quantity should be 14.65. So let's check it with our supply. So our supply again was that 50 plus 10p. Our p is that 36.67. 50 plus 367. All right, and these are about the same, right? They're round because we had to round with this, so we're gonna have to round a little bit with that. So in this case, this one's 416.7, and the other one was 416.65. You can kind of see it a little bit better here. Right. All right, that tells us our new equilibrium then. Our new equilibrium, like I said, is going to be at a price of 36.67. We now have a quantity of about 416.7. There we go, there's that one. The next thing we have to do is we have to graph these, right? It's a little bit easier to graph it on Excel because we have our table, we plug it in. But if we want to graph it by hand, it should be just as easy. We're just going to erase this. The thing we need to remember when we graph supply and demand is what goes to what axes. This is the most important part because it's a little bit different than if we just did it normally algebraically, just because we have a different relationship, right? Our y is usually on this axis, our x is on that axis. The way we write out our things, it looks a little bit different, right? We would think this would be our y and that would be our x. No, it's a little bit different than that. This is always our price. Whether we are in a labor market and this is our wage, or we are talking about a finance market, this is always going to be our money. This is our money. Money talks. And this is our quantity. Right? Price, quantity. So the way we're going to do this is you don't even need to have them touch the axes if you don't need. We just need we need to know the basic relationship between these two things, right? We know first supply, blue supply is an upward slope. So our supply goes upwards, and we need to label that bad boy. Supply, upward slope, law of supply, higher price. They want to make more money. Our original demand is a downward slope. Oh, my marker is losing its lust. All right, we need. All right, demand, first demand. It's going to be this dark blue. This was our first demand. This is going to be. We're going to want to label this, right? We want to make sure we label everything. I'm going to call this the original. I'm going to call this the O. Our new demand is green. Our new demand is higher. This is our demand. We can call this demand prime. We can call this demand 1. We just need to indicate that we have shifted upwards, right? And then the most important part is our equilibriums. If we want to label these, I would absolutely recommend it. Give them a little dot. Our original equilibrium, right, looks something like this. We had our original, we're going to call this E1, and this is E2. These dotted lines are telling us our equilibrium price and our equilibrium quantity. So remember, our equilibrium quantity, the first one was 350. The second one was 416.7, and then our prices went from 30 to 36.67. And there we go. The last thing is we need to explain the kind of cause and effect. And I've kind of already said a little bit about this, right? The influencer and their interest in our pastries in our little bakery shop made it so that there was more demand. There was a little bit of hype around it, right? And that means our shift of our demand to the right, demand went higher. People wanted to consume more. And because they wanted to consume more, we had both an increase in the quantity demanded, or the quantity sold, or the quantity in our marketplace at all, and we had an increase at price. The next question, question 4, is on price ceilings and price floors. So I just want a little bit of a reminder of what we kind of look like when we see a price ceiling and a price floor. Remember, when I talk about a price floor, think about the floor itself, right? That's the lowest price you are allowed to set in a marketplace. If I have a price ceiling, that's the highest price you are allowed to set in a marketplace. Examples, especially we see things in like rent, we might see a price ceiling. This is the largest you can charge, or the most amount you can charge for rent. And in the labor market, we're going to see price floors. This is the lowest, aka the minimum wage, a price floor. That's the lowest you can pay people in a marketplace. So if we just have our supply and demand, right? If we have something and it is below our equilibrium, right? You see how this is below equilibrium? If something is below equilibrium, no matter if it's a price ceiling or a price floor, this is the effect it's going to have. If it's below equilibrium, we're going to see this. We're going to see demand is going to be greater then supply. And if we have demand that exceeds supply, so there's more demand for a good than there is the supply of a good, we're going to see a shortage. There's not enough of it. If we have the opposite situation, whether it's a price ceiling and or a price floor, and we have something that is above our equilibrium, we're going to see supply exceed demand. So supply will exceed demand. And in this case, we're going to have a surplus. What this means is that we have too much of that good, right? Supply is exceeding demand. We have too much supply. We've produced too much. And we don't have the demand or the consumers to want to consume said good. So in our example 4, we're talking price ceiling or price floor. In this example, we say the town of Yarmouth is concerned about affordable housing and announces a policy change. Use the rental market below. So our rental market looks like this. Our demand in this market is, the demand for housing is this. And our supply of housing looks a little like this. In this case, right, we recognize some things. We can see that this -2 is indicating that downward slope for demand, and this +3 is that upward slope, right? That's the relationship between price and whatever quantity is demanded or supplied in our given place. So this is our unregulated marketplace. This is without regulation, so without a price ceiling or a price floor or any kind of intervention. In this case, the first thing what we need to find in our first question is to find the unregulated equilibrium. Just like we've done before, equilibrium is is our happy place. This is where our two lines cross. If we were talking about this as just a system of equations, our equilibrium again is right here, where these two lines cross each other. In this case, we find our equilibrium by setting these equal. And we're going to solve for P. This case, I'm going to subtract 200 from both sides. That gives me 1,000 minus 2P equals 3P. We're going to add the 2P to both sides. That's going to give me 1,000 equals 5P. 3 plus 2 is 5. And then we're going to divide both sides by 5. That's going to give us 200 is the price. So, first thing, we have our price. In this case, it's at a price of 200. What do we do now? We plug this value back in, right? Now we gotta find our quantity. We gotta make sure if we're in equilibrium that our quantity for supply and our quantity for demand are equal. So we're gonna write this. This is our unregulated equilibrium. In this case, we've decided P is 200, and now we need to find Q. So let's find Q. Well, let's plug this in. So we got 1,200 minus 2 times 200, or P. That's 1,200 minus 400, or 800. Then supply, 200 plus 3 times 200. That's 200 plus 600, and that's 800. There we go. Quantity, 800. So in our unregulated market, we stand at a price of 200 and a quantity of 800. Now we need to add a price ceiling. So in this case, it's going to look a little different. What a price ceiling is doing is setting the maximum, right? So in our marketplace for housing, we have our price and our quantity of housing. We have our demand for housing. We have our supply for housing. And in our marketplace, our equilibrium sits at a price of about $200 and a quantity of 800. That's our equilibrium. We have introduced a price ceiling of 150. 150 is below 200, right? We have a price ceiling. We're saying in our marketplace, you can charge a maximum of 150. We need to determine what our new quantity demanded and what our new quantity supplied would be at this price of 150. So we're going to determine what this point is and what this point is. How do we do that? We are just going to plug this 150 in for the price in both equations. That'll give us QD equals 1200 minus 2 times 150. So 1200 minus 300 or 900. That's our quantity demanded. Do the exact same thing for quantity supplied. So we got 200 plus 3 times 150. That's 200 plus, if we know 2, we know this is going to be 450. And this is 650. We come over here. 650. What do we see here? We see quantity demanded is exceeding quantity supplied. The last part of this asks us to determine in this marketplace, right, when we graph it, do we have a shortage or a surplus? In this case, right, we have demand that exceeds our supply, right? If our demand exceeds our supply, that means we have a shortage. And if we want to think about this just logically a little bit, right? Just think about the situation through. If our equilibrium, where we have enough housing, we have enough supply to meet the demand for housing, sits at this 200. Remember, the law of demand says the cheaper things are, the more people want to consume. So if we set a price of 150, more people are going to want to consume that. But just because more people want to consume it doesn't mean supply is going to increase, because supply has the opposite rule, right? The more expensive something is, the more they supply. The cheaper something is, the less they supply. All right, question 5 talks about a labor market. So now we're talking price ceiling, price floor again, but now we're talking in the labor market. So in our market, Island Shake is a restaurant in Cape Cod, and they hire many part-time workers during the summer. We want to see how a minimum wage would influence employment. So in our market, we have labor demand and we have labor supply. Remember, this works a little bit differently than it works with what we've seen before. So in a labor market, the supply of labor is the employees themselves. And the demand for labor is how much labor employers want. So we have our labor demand of 200 minus 5W. And remember, we still have that negative demand and that negative slope because if you get paid more, you want to work more. If you get paid less, you want to work less. And then our labor supply is 20 plus 10W. So this is our labor. So we want to figure out how minimum wage is going to affect this. So the first thing we want to do is we want to solve, just like we do before for our equilibrium, without any of this intervention from minimum wage. So we're going to set these two equations equal. That'll leave us with 200 minus 5W, remember the W is wage, equals 20 plus 10W. Now we're going to do the same kind of math we've been doing, minus 20 from both sides. That'll give a 180 minus 5W equals 10W. Add the 5 to both sides. That'll give us 180 equals 15W. Then we're going to divide by that 15. And we're going to get a wage of 12. So, in our original marketplace, so our original equilibrium, we have a wage of $12. And now we need to find out what our labor is going to look like. How do we do that? Same thing we've been doing. Take this value, plug it in here, make sure they add up. All right, labor demand. Labor demand is 200 minus 5 times 12. That's 200 minus 60. That equals 140. If we did this right, same thing should happen for labor supply. Labor supply is 20 plus 10 times 12, which equals 20 plus 120 equals 140. All right, our labor then is 140. That looks about right. If we want to draw this on out, our y-axis, remember that's always like our price. In this case, that's our wage. Our x-axis is our labor supply, labor demand. How much labor? What's the employment like in our economy, in our situation? So we want to draw demand, we want to draw supply, and then we want to label our equilibrium. In this case, our equilibrium is right here. Our equilibrium wage is $12, and our labor at that is 140. Our next question is telling us that we have a new policy. The government is setting a minimum wage of $15 an hour. This minimum wage is above our equilibrium, right? 15 is greater than 12. In this case, what we're trying to look at now is what that does to our equilibrium and what that does to our marketplace. So we're trying, just like we did with rent, we're going to identify where supply and demand are. How do we do that? We plug some values in, of course. All right, so we have our labor demand. That's that 200 minus 5. And for a W, well, it's $15 now. $15 buckaroos. That means it's 200 minus 75, or, and then we gotta do 200 minus 75, 125. We take this on over, up, 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 up. Our demand's over here, up, 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 up. 125. Same thing with supply. Labor, supply. The employees. 200 plus 10 is 15. 220 plus 150 is 170. Up, 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 up. 170. Now, we can see here, 125 is less than 170. 125 is our demand. This is our supply. So our demand is less than our supply. If the demand for a good, in this case the demand for labor, is less than the supply of labor, we have that surplus. So we have a surplus of labor in our marketplace. Is question number 6. This talks about elasticity. This is the most mathy we get, right? This one's a little crazy, so we gotta go, stick with me, and we gotta go through part by part. So remember, the point of elasticity is to measure responsiveness. So it measures the elasticity of demand, measures how responsive consumers are to changes in prices. And remember, consumers respond to changes in prices by changing the quantity to which they consume. So in this case, we know generally the law of demand states that the higher the prices, the less consumption. The lower the price, the more consumption. What elasticity is showing us is really the slope of our demand. So in this case, if I have 2 prices, I can have a price of P1 and I can have a price of P2. At P1 and at P2, we have different kind of situations that occur. So if we want to look at this first demand, we're going to call this D1. This is a much flatter slope, right? It's almost close to just being a horizontal line. At D1, our quantity consumed, the quantity, there's a huge gap, right? We're super responsive. We're super elastic. At D2, this other line, right? We're way less responsive. We're way more inelastic. Of course, we change the way we consume, the prices change. But it's definitely not as crazy as we are if we're very elastic and very responsive. That's what we're measuring when we talk about elasticity. And we do so numerically because we have to think about elasticity in the way we think about like a rubber band, right? Super responsive, you're super elastic. If you're not responsive, you're inelastic. Not much pull to your rubber band. So the way we measure this is with our elasticity or our midpoint formula. Because all we did there, right, was look at a P and a P and a Q and a Q. And that's all we're comparing. We're comparing how P changes and how Q changes. So in our situation, the Hyannis Cinema is adjusting their ticket prices for the Blockbuster weekend. In this case, we have two different situations that occur. We first have a change in our prices. In this case, prices go from a price of P1 of $10, that's the first price, to a price of P2, which is $12. Movie theater thinks they're gonna fill the seats, they wanna make a little bit more money, they charge $2 more. What we see as a result of this is a change in supply and a change in demand. We first are going to look at demand and then we're going to look at supply. This calculations are pretty similar for both of them, the way we calculate it. It's just the numbers that change. So we got price. Let's look at the change in demand. So demand falls. That's what it tells us. Demand falls. Why does demand fall? Prices went up. Prices went up. People won't consume as much. Demand is going to fall from a Q1 of 500 to a Q2 of 440. All right, demand falls. We want to see what the change in price did to the change in demand. And that's going to measure how responsive people were to this. What do? Well, we have to use our elasticity or our midpoint formula. It looks a little bit like this. Elasticity measures the change in quantity over the change in price. Remember that little triangle means change. This is a percent symbol, so we're looking at this percent-wise. What this really ends up looking like is this super crazy formula, but if we break it down by parts, it starts to make a little bit more sense. Because remember, we're really just looking at how each individual thing changed, price, and how quantity changed, and just comparing them. How do we do that? Well, when we focus just on quantity first, we take first our new amount, right? The new price. And we take the difference between the new price and the old one. New quantity, old quantity. We take the difference. So what do you do when you take subtraction? Product difference. We divide that by the average quantity consumed. An average is adding things up and dividing them by how many things you added up. We have two things. We got the quantity 1 and quantity 2. So we divide by 2. If we had quantity 1, 2, 3, 4, 5, we divide by 5. If we had quantity up to 20, we divide by 20. This is it. We do the exact same thing. Sorry, I messed up the colors. Remember this, that. And then this will be this. We do the exact same thing for price. The first price is taken from the second. Second price minus first price. We take the difference. Then we take the average of those two prices. And we divide, right? Add together, divide, average. So, what do? We plug this on in. That's all we do. We just plug the values in that we're given. If you do this on a calculator, go for it. All right. Let's plug those bad boys in. Marker that works. Oh. Okay, that one's fine. All right, let's focus on quantity first. So, we went from a quantity of 500 in our first period to a quantity of 440. Start at the top. 440 minus 500 over 440 plus 500 divided by 2. Right, we're just focusing on that quantity first. We focus on the quantity first. This minus this is going to be a negative, right? Negative 60. Remember, this makes sense because the law of demand, higher price, less people want to consume. We see here the change. We went from 500 to 440. 440 is less than 500, so we went down. Percent down, 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 down. The next thing, we do 440 plus 500. 440 plus 500 is 940. We divide that by 2. What we're going to get is 60 over 60 over 470. And then last thing we want to do, divide that, divide. That's going to give us about negative 0.1277777777. We've made it. This is our first step. We did quantity. Now we're going to do price. Halfway there. Remember, this is over something each single time. Price. Our price in the second period was 12. Our price in the first period was 10. Over our average, 12 plus 10 divided by 2. That equals 2. Remember, prices went up, so the percent change is going to be positive. We're going up. 2. This is 22 divided by 2. 12, 2 over 11. 22 divided by 2 is 11. This is going to give us 0.1818. Last step, divide those. What is that going to give us? We're going to get price elasticity of about 0.702. 0.702. So when we take elasticity, we're going to ignore this negative, which means we're taking what's called the absolute value of this. Absolute value is how far something is away from 0. So if I put this on a number line, right, if this is negative 0.702, it's still a distance of 0.702 from 0. So this is what relationship to 1. Remember, that's the whole thing about elasticity, is its relationship to 1. 0.702 is to 1. It's less than. And if it's less than 1, that means our demand is inelastic. That means, did less people consume the movie tickets? Yeah, but did they care really that much? No, they weren't super responsive. The last thing we need to check out is our responsiveness to supply. So we gotta do this whole thing again, but with supply instead. So again, demand, elastic, demand, inelastic. Let's figure out what supply is. repeat from here on. Just gotta erase the rest of this. All right. In this case, it told us, once again, let me write these in the right colors. Our price we went from a price of $10 to a price of $12. In this case, prices didn't change. What does that mean for us? Well, we're in good luck. We don't have to calculate the elasticity of price again. Remember, price was at 0.1818. It didn't change. Didn't change from the last calculation we did. Now all we have to do is do the change in the quantity supplied. Our quantity supplied rose. Went up. We went from a quantity of 300 tickets to a quantity of 360. Maybe they opened up the extra fancy theater for us, or they put in a few more seats. So let's see what our quantity change looks like. We have Q2 360 minus Q1 300 all over the average, 360 plus 300 divided by 2. So we got 60, 360 minus 300. 360 plus 300 is 660. We divide that by 2. We get 60 over 330, or we get 0.1818. And would you look at that? 0.1818 over 0.1818 means that we have a case of unit elasticity. That is a 1. A 1 is equal to 1, and we are unit elastic. So in this case, our supply is unit elastic.